Welcome to a new composing visual music tutorial. In this tutorial, I'm going to talk about rotations in Jitter. We're not going to do a whole lot of audio, but I'm going to build in the next tutorial. I'm going to build on this one to introduce sound in connection to the visuals. Right here I have a cube that I can visualize with a grid shape, and I gave it a scale attribute on the 3 dimensions, lighting, just to appreciate the different rotations of this object. Let's see how we can rotate. So every grid shape as an attribute has actually 2 rotating attributes. One is rotate XYZ, which is my Euler rotation. So I can rotate the cube on the X dimension, so meaning around the X axis, and this is in degrees. So 360 is a full rotation. Or I can rotate on the Y or on the Z, etc., etc. So the rotate XYZ is a Euler rotation, while the rotate without the XYZ is an axis rotation. What that means is that I have an axis around which the object rotates. So if I, for instance, just create a vector, and the first argument would be the rotation in degrees, and the last 3 arguments are the vector in a 3D space. So a vector 0, 1, 0 right here will be just a y-axis, and if I rotate that, my object around the y-axis, that's exactly like a Euler rotation. Okay, the next step is to observe how to rotate an object around an axis, like the position of the object around an axis, rather than the object itself on its own axis. So what I can do is, first of all, this is a small variation of what I did before, and I'm creating an axis that go actually on the positive and negative direction in my 3D space, and it's orange. Then what I can do is create an object by creating a matrix with 1 point only. Make sure that that's always triggered, and then use the same multi-slider to create a new position. So now I have my axis with my rotation value, and this is just to visualize my axis, and then I have another multi-slider to change the position of an object, and I want to go through a different kind of rotation. So I want to go through a Jitter. The object to create rotation in Jitter is the QRot. the Q stands for quaternion rotation, which is computer graphic standard to do rotations. And while the math behind it is kind of complicated, the idea is to use an axis rotation just like the one we used in the previous example. And the rotation attribute inlet is the left one. So if I create a parameter, call it rota, and then give it 4 arguments, because we saw from last time, from the previous example, that actually axis rotations require 4 arguments. And this will be my position to be rotated. So the quaternion works, as I said, very similar to my axis rotation, but I do need to make a conversion, and Jitter has an object to do just that, which is called axis to quaternion. And since my parameter inside the JITGen is called rota, then I have to prepend the parameter name to do that. So now we're rotating not the object, but the position of the object around an axis. So that's that. So if the object is in that position right there at the center, or let's put it up there a little bit, and then start rotating, it will rotate around this axis. If I change the axis, then the rotation will happen again. It will keep rotating around that axis. So this is a more better way, I think, to do rotations rather than use the Euler rotation, which can get really hard to calculate if I want to do variable axis rotation. There are different ways of doing this, but what I can do is to concatenate the current position with previous positions. And I can use a JIT matrix with the user dimension so that I split the tail, like I get rid of the last cell each time I go through it. Or I can do, this is what I found on the forum, something a little more elegant, use the split, JIT split, and the split point will tell me how long the trail is in terms of how many objects there are. So we can be generous here, since that's all we're doing. So we're gonna have 121 objects, because I'm gonna concatenate the 220 with the current position, and this will be the last object. So if I do an FPS GUI and track the dimension of these guys, then let me see, boom. So it's building a trail. Now it will stay 120, and this will be the last point that I'm discarding, pretty much. So now I can use a GL multiple, and 3 parameters. GL params are position, scale, and color. We're going to use the old-fashioned expert object. So I'm going to use the normalized coordinate on the x dimension. So this is a row matrix. So the first cell will be 0 and the last one will be 1. So to make that a color that makes sense, then I can do 1 minus the normalized coordinate. And that will give me 1 on the first cell and 0 at the last one. So I will have a fading away, like a increasingly darker trail. And then I can repeat that. I can repeat that on all the color channels. And that will be my color. Not that. So here I'm not actually using the data that's coming through here, the values that are in this matrix. I'm just using the dimension to give some sort of coloring. And I'm gonna do something similar for the scale, but I want a smaller scale. I want the scale to be maximum 0.06. So I can do 0.06 minus norm 0, because I'm using the x again. I'm using the x normalized coordinate, and multiply that by 0.05. And this will be my scale. Again, I'm not using the data there. Last thing is to connect this the multiple with the grid shape. And now if I rotate, I can see how my object is rotating. I can see clearly how the object is rotating around the axis. Change the axis. Okay, there you go. So we're gonna use this in the future to create some visuals for sound. I find that rotations are a cool way to approach movement when visualizing music, because it's a motion that by definition is self-contained. And so it allows us to create a bunch of movements that are contained in the screen that we work with. And so we'll see how to do that in the next episode. And I am going to post this more often now that I'm on a break, supposedly. So I hope you enjoy this, and I hope you keep watching it. And I hope you will subscribe to this channel.